we're going to basically start with library functions. So can anybody tell me what functions may be in a real world context? Like,
It helps us to complete a specific task or many tasks together.
perfect. A function is, you can say it's about performing a specific task, or it has many subtasks inside one major task that it performs. Can anybody give me an example of a real world function, a name of it? And let's try to discuss what the tasks there are. Like, what are the functions that we can think of in everyday life? Okay, so
Household chores.
household chores, perfect. So can you give me one of the subtasks in that, sub-functions in that? See, household chores, it's a very good example, but it's very general, right? We have a lot of subtasks. So can you give me one specific task there?
Washing the utensils.
Washing utensils, perfect. So we have something called washing utensils, right? That's our task name. So can you tell me what sort of things we require to wash vessels? What would be the input there, or what would be the starting point? What do we need to wash dirty vessels?
Water.
Water, perfect.
There's resources we need to
Yeah,
clean.
dirty vessels, soap, and things like that. So the dirty vessels, water, and soap are the input into the function. So I'll just try to write down a function like that: public void public washed vessels. Okay, wash vessels function. You guys have studied the basics of functions, have you?
Yeah.
Okay, perfect.
Yes,
So
sir.
then you'll try to get what I'm going at. Okay, so so these are, so what are the input types there? So we'll have dirty vessels, we'll have water, and we'll have soap, right? And what will be the output here? By this, you should be able to guess of what type the output will get.
Substring.
No, see here, right? In basically, right, what this specifies is basically an access specify that we don't have to think about now. What this specifies, right? The second part always specifies the return type. So when I have something like public void in a function, what does that say?
There's no return time.
Exactly. Void means there is no return type. Now when I say the return, now what is the return type of this function? So the second
String.
washed vessels, yeah. I mean, no. String is a class. I'm just telling, like, don't think about like our like data types in the past. We're just talking about some brand new concept, right? So here our return type is of washed vessels, and the function name. What's the function name here?
Wash vessels.
Wash vessel, exactly. And the inputs our function is taking is dirty vessels, water, soap, and these are the input types our function is taking. And the output will be something of type wash vessels, right? So that is basically how functions work. Now we have taken a real world problem and we modeled into like how we need a function to look. So what is the task that is being performed in this function?
So washing the vessels.
Washing the vessels, perfect. So that is the task. So like this, right, we can always define a function as something that has a return type, something that has a function name, and something that takes specific input, okay, and it gives a desired output. So this is what a function does. And now coming to the next part, what do you think are library functions? What would
Predefined functions.
predefined functions? What a beautiful answer. So why do you think we need predefined functions? Like there must be some reason, right? We have predefined and user defined functions and things like that, but why do you think like they made, like, who came up with the whole concept of predefined function? What could be the use for us?
So to make easier stuff easier, like for example, power of proof and all of
So
them.
we have two concepts, right? We have predefined functions and user defined functions. So basically Java, and I mean any program, somebody's joined the call, I'll just let them in. Yeah. So basically, any programming language, right? It allows us to define our own functions to perform certain specific tasks. For example, in our last example, we had the wash vessels function, right? So that would not be a function that is already covered in this Java programming language. So that time we'll have to define that function. But for some functions, right, the developers thought, wait a second, these sort of functions will always be used by the user. So why not let's build it in the most efficient way possible and give it to the user. So right away he can start coding with them. But again, now comes to the second question, right? You see, right, some of the times the functions in our programming language, right, the predefined functions, we have to import them, right? You saw the previous example when I'm saying java.util.scanner. So the class is already predefined and the functions associated with it are predefined, but I'm still having to import them. So why do you think that would be the case? Why do I have to import it? Why not? Why not just give it? Give all the predefined functions. Why not just declare it within the class itself, like the developers themselves? Why didn't they give all the functions at once? Why are they giving us the ability to import these functions and classes? Hmm. Any guesses, guys? Any guesses? Even if it's wrong, it's fine. See, these are not like technical questions or something that we need to be correct with. These are just questions like we think why certain things work in a certain way or not. So even if they are wrong answers, probably it'll bring us to a new way of thinking. So any guesses, guys? Anyone? Any answer? Come on. You can tell me anything.
Repeat the question.
Yeah. So why do you think they've allowed us to import certain classes and functions? Why do you think that they have not just written it predefined and we can use it straight away? So why is
So,
yeah?
so is it because like to use a particular class from the package we want?
Mm-hmm. Yeah, that's a very good answer, right? So only when we have to use a particular class on the package we want, we have to import things. See, or else there are so many predefined functions, and if we just have everything like inbuilt into our programs, right? It doesn't make sense because we'll be using a lot of space to perform. Let's say you're just adding two numbers, right? When you're adding two numbers, you don't need functions related to the calendar class. You don't need functions related to the scanner class and things like that. So that is why they allow us. They have certain predefined functions, and when we want to use them, we can import them. So we that's why not all of the functions are built in. And the biggest problem there, right? If many of functions are built into your program automatically, what happens is you're using a lot of space with very little functionality. And programming is about the reverse. You have to use as less space as possible to achieve maximum functionality. So that is why there are predefined functions and we are allowed to import them as and when needed. Okay. Now, coming to the third question of the day. What do you think strings are? Anybody? Any guess? String.
For text.
Mm-hmm.
Data type
Yeah,
for
string is a
inputting.
data type. That's a good answer. But what is like? Yeah, I just understood a very little about strings now. Okay, they may be some sort of a data type, but I don't know much about them. Tell me, guys. Explain. Like,
It's those characters with that data
mhm.
type.
Exactly. It stores characters. Got it. Anything else? Anything else you guys want to add on to that?
So it is enclosed with double quotes.
Perfect. That's a good answer. When you write it, we have to specify it in double quotes. What is the difference between strings and characters? Like coming from that point.
So characters, I mean, it's a single synonym string can accept, like a
Exactly.
sentence.
Yeah.
That
In
is-
other ways, we can say like a character is like the smallest unit of a string, and using these smallest units, we can build a larger strings. Okay. And one technical thing about strings in Java is they are immutable. That means once when you define them, you're not basically allowed to change them in the runtime. Okay, like append things or something. But we still find ways to do that. I'll show you ways that we can still play around with them. But in general, they are referred to as immutable, right? Strings. You can't change them once you're in runtime. Okay. So for strings, right, we have certain library functions to actually expand their functionality, we can say. So I'll just get started with some of the I think you guys can see the screen, right? Some of the function names on the top.
Yes.
Yeah.
Yeah.
Let's just go function by function and see what each function does. Okay. So let me just start with one of your names. Okay. String name is equal to Akshay. Okay. See, whenever we're discussing about strings, I want you guys to understand what the return type of a string is. So that is what makes the difference between a good programmer and a great programmer. Okay. So a good programmer will know the names of the functions and stuff. But when it comes to actually understanding the return type and how to utilize them effectively, it's really important to understand what sort of data type they're returning and in what cases we can use them. So let's just look at the first thing. Okay, length. What do you think the length function does?
It stores the input of the user, like the user tells an input of the length value and it stores it.
Okay, I'll just show you how the length function is written. Okay, so what do you think the return type of this would be? Name dot length. So, and this is just the prototype of how we call functions associated with strings. So we have the name of the string dot and the function for the string that we are calling. Okay, so I'm saying I want the length of the string. So can you guys tell me what that might print out for the string Akshay?
6.
Perfect. Let's just see. Let's see if that does that. We are on the right track. Okay. So it's printing out 6, right? So this is how, right? String.length is a function that prints out the length of the string, right? So they actually made it pretty clear to us. Okay. Can anybody tell me what are the input parameters of this function dot length? What are the inputs that we're giving to it?
First of all, a string name we have to give.
Okay. See, length function, right? You guys know classes, right? Classes and objects and things like that.
Yes.
Yeah. So basically, right, the class name is string, and in the string class, where this function called length is stored. Okay. And basically, this length function we are calling, and this is how we are calling. This is the function signature for it. So can you tell me if there are any input parameters for the string?
No, sir.
No, exactly. So it doesn't need any input parameters. And what is the return type? Return type.
Int.
Int. Perfect. So this it returns an integer representing the length of the string. Okay. Now let's come to the next thing. Concat. What do you think concat is?
Concatenation.
Concatenation.
Concatenation. Perfect. That's a very complicated word, guys. Can you tell me what concatenation may mean?
Combination of any two strings.
Perfect. Perfect. So let's just see. Akshay, can you tell me your surname? Okay.
So it's Rm.
Okay. So let's say name dot concat rn. Okay.
So Rm and
Yeah. Okay. Let's just go. Like this is your full name for today. I'm sorry about that. Yeah. So system dot out dot println full name. Okay. So let's analyze the question in the same way. We are using the string name, and we are saying dot concat, and what is the input parameter here? What type is it?
String.
String, yeah. So it accepts one string data type, okay, so that you can pass to it. And we're doing name.concat rn and storing back it into full name, okay. So that is the how the concat function works. So let's just see the output. So let's run this. Okay, so see Akshay rn, that's what we're getting, right? So it's basically combined these two strings and stored it in full name. So one other word you can use for this concat function is append. So append is basically when you're adding something to the end of another thing. So you're like actually like let's say you have your arm, right? You can append your fingers to your hand or something like that. So you're basically adding the second part of at the end of the first part. So that's called appending. So can you guys think of any other thing like appending? Thinking. Okay, like let's say like a tower is being built, right? So you build the base and then you append the first layer of bricks, then you append the second layer of bricks, third, fourth, and so on. So you're actually building the tower by adding things to the end of it. Okay. Now we any questions, guys? Any questions so far regarding the first two string functions?
No, sir.
Okay, perfect.
Yes.
Okay, now coming to the third string function, right? Compared to, what do you think the compare to function does?
Compares the length of two strings.
Compares the length of two strings. Okay, it's a very good
Just
method.
generally
Very
compares
good.
two.
What is the second answer?
So generally compares two strings.
Yeah, compares two strings. But okay, have you guys seen the dictionary, right? How have they arranged the words?
In order of the alphabet.
Alphabetical order. Okay, so when you're arranging the words in the dictionary, you need to follow a certain order called an alphabetical order. But the word we use for it is called lexicographically. Right, so lexicographically, the easiest way to understand is just think about the dictionary, how the words are stored in the dictionary. That is called a lexicographical order, right? So that is what the compare to function does. It compares two strings and tells and returns -1. I'll just show you how the function looks and you'll get a good picture of it. So system.out.println hey and dot compare to hi. Okay. So what this function does is, right, it compares the first string to the second string. Okay, see, this is one other way, this is one other thing that I want you guys to understand. See, first we are giving the variables, right? We are saying name.length and name.content. You can even call these functions with the string constant names itself, right? As constants, little constants. So this is because, see, basically this is also a string, right? It's enclosed in double quotes. So this has the same functionality what the string variable has. So that's why I'm allowed to call the string functions using this sort of constant notation. Okay. So hey dot compare to hi, right? In the dictionary, which will be stored first and which will be stored second?
Here will be stored first.
Hey will be stored first. Okay. So let's just run the output and I'll explain the output to you. It says -4. Okay. So let's analyze why it might be -4. I'll just explain the output. So it returns a negative number if the first string goes before in the dictionary. Okay, if hey goes before hi in the dictionary, it returns a negative number. If both the strings are lexicographically equal, it gives 0. And in what case will they be lexicographically equal?
So both of the string words.
Exactly, that's such a good line of thinking. So, and it returns a positive number if the first string is lexicographically greater than the second string. Okay, can anybody tell me a word that will go after hi in the dictionary? Let us say sleep. Sleep should be lexicographically greater than hi. So let us see the output. See, you get a positive number 11. Why? Because the first string is lexicographically greater than the second string. Okay, so now what are the input parameters for the compare to function? It takes in
String type.
one, yeah, it takes in one string type. Okay. So coming for the last two functions of the first phase, okay, whatever. Equals. What do you
So what does lexicographically mean?
Yeah, so like basically like the simplest way to understand is how you see words stored in the dictionary, right? Like in alphabetical order. Let's say Ramesh will go before Railu or something like that. Let me just put it down. Railu, right? So in this, right, Ramesh will go before Railu in the dictionary. So basically that means Railu is lexicographically greater than Ramesh. So I don't know how you technically explain what lexicographically is, but this is the easiest way to understand, right? Lexicographically means like dictionary wise comparison. So and something like
So why is Ramesh go before Raidu? Like
Okay,
into the
so
dictionary.
you look at the dictionary, right? So I'll just show you how the dictionary might compare these two things. So both start with the letter R, right? So both are in the, they'll be stored in the R page of your dictionary. Then we'll come to the second character. You see the second character in Ramesh is A, and the second character in Railu is Y. So which comes before? A or Y?
So then, A.
Exactly. So then Ramesh will come before Railu in the dictionary. So that is how things are stored in the dictionary, right? So what happens in thing like rat and rain? Okay. So what do you think? Which do you think comes before in the dictionary? So the first two characters it checks. It checks that both are the same. Now it goes to the third character. The third
So
character is
rain will go first.
rain will go first. So that is the lexicographical comparison. Okay. So that's how you can compare two functions.
Okay,
And
so understood, sir.
yeah,
Yes, understood, sir.
yeah, perfect.
Excuse me.
Yeah.
Sir, when you ran the output, sir, yeah, I mean, it gave a negative number and a positive number, sir, but on what basis is that number displayed? That is, what is 11?
Okay, what is 11? Okay, so one guess, okay, I don't know exactly because what sort of lexicographical comparison is happening there. I'll just check it out, what the return types are. But that's like the basic rule of thumb that we use. If one is greater than the other, it returns a positive value, and if it is lesser than the other, it returns a negative value. But what exactly those values specify, I'll actually have to read about it. So compared to Mhm.
Right.
Okay, yeah. So basically, right, this is like the basic explanation we get. If S1 is greater than S2, it returns a positive number. Otherwise, it returns a negative number. But I'll just tell you the next time, okay, technically what sort of comparison is going on in between the two strings. But as a general rule of thumb, for now, you can remember that this case. If S1 is greater than S2, it returns a positive number. If S1 is less than S2, it returns negative, and both are equal, it returns 0. Right? For now, you can just use that as your general guidebook, but I'll tell you the next time what it exactly compares. Okay.
Right, sir.
Hmm. 1 second. We may be able to guess this. Okay. So when we wrote hey, so EFGH. Okay. Let's see. -4. Okay. So what happens if I write HG? So this should be. Okay. So see, this starting to make sense now that I think it's this way. So now when I write HH, it technically should return -1. Yeah, so we are getting somewhere, guys. Just hang on. It's a very good question. So technically, according to us, rat and ray, right? So this should return A, B, C, D, B, C, D, E, -4, I guess. Let's see. Yeah. So this is what it's doing. It's a good question. Whoever asked that. So basically, right, it's comparing the first character. Okay, and it's saying it's all the same character. Now it goes to the second character. In the second character, there's a difference, right? One is A and the other one is E. So it's just saying how far apart these two letters are. A, E, so A, B, C, D, E, right? So B, C, D is 3 letters, and 3 plus 1 -4. Okay. So now if suppose this becomes R, F, Y, it should give us an answer of -5. Let's see if that's the case. Yeah, so that's the case. So, and even now if you replace this as RFT and this as RAY, it should give +5 if I'm not wrong. Let's see. Yeah, so that's what it does. Whoever asked the question, right? It shows how far these two characters are from each other when representing them in a dictionary, right? So that's what it does. The lexicographical comparison. You guys got that? Yeah.
Yes, sir.
Yeah.
Yes, sir.
I mean, again, see, any doubt, okay, even this one, I figured it out because it was such a good doubt that you guys asked me. And until today, I never knew what they actually compare. I just knew that if one is greater than another, it gives positive or negative. But that's such a good doubt, okay? And if I've not understood it, it's no problem. I've come all this while without knowing what exactly the comparative function does, okay? Now, going to the next function, equals. What do you think equals does?
Equates to strings.
Yeah, it equates two strings and tells if they are the same string. And what sort of, okay, this is like a question, right? Can you tell me if these two strings are equal? So, what sort of answer will the computer give me back?
No.
No or?
Yes,
Yes.
Boolean.
No or yes, right? So, what will be the data type of the return answer?
Um,
Boolean. Perfect, perfect. That's such a good, yes, okay. So, let's say Ramesh dot equals Sukesh, right? System dot out dot println, they are the same. Else, okay. So again, what is the input parameter here for equals?
String.
String. And what is the return type of this function?
Boolean.
Okay. And what is the return type of this function?
so int.
Not quite, not quite.
Just
I'm assigning this to a string value, so it must logically mean this is a string. Exactly.
string on the string. Yeah.
That's a good guess, right? So let's see this. If Ramesh dot equals Sukesh, system dot out dot println, they are the same. Else system dot out dot println, they are not the same. So let's see what the output here is. See, they are not the same. Okay, now if Ramesh equal to Ramesh, let's see. Sorry, they are the same. Okay, that's good. That's good. Is Ramesh equal to Ramesh? They're not the same. Oh my god, they're supposed to be the same. What do you think is going wrong here, guys?
The uppercase and lowercase. You have to
Exactly. So Java is basically like this case sensitive language, right? So this string and this string do not mean the same thing. Okay. So when we are trying to say if these two strings are equal, it's actually going in calculate and saying, wait a second, these two strings are not equal. This A is in uppercase and this A is in lowercase. So I think there's another function. This you might not have in your portions, but now this function, what it does is it ignores case, right? So Ramesh dot equals ignore case this Ramesh. So basically, it converts them in both into the same. It gets rid of the cases of each of the letters and just compares the characters. So that's what equals ignore case does. But that is, I don't think is it's ahead of our portions. Only this much. Ramesh dot equals Ramesh. This one we'll be using. Okay. Now we okay. Just to reiterate, right? What was the first function we learned? Length. Okay. So what were the input types of length? Input parameters?
String.
No. Input parameters for length.
So not.
Oh yeah, nothing. We had to give it nothing. And what data type it returned to us?
Int.
Int.
increase.
And what was the purpose of the function?
To calculate the length of the string.
Exactly. So whenever you guys are analyzing a function, right, always use these three steps. What are the input parameters for that? The first thing you'll obviously know what is the name of the function. So I'm not going to reiterate that. So analyze a function in three ways. What is the input parameter? What is the return data type? And what the function exactly does. Okay. Now let us apply that to the second string. What is the input parameter for concat function?
String.
String. Perfect. What is the output data type?
Just a string.
Perfect. So what does the concat function do?
It joins the both the strings together.
Correct. It appends the second string to the end of the first string. Perfect answer.
Yeah.
Now the third one, compare to function. What does that do? what is the input parameter?
So string.
String. Perfect.
String.
What is the output parameter? I mean output data type. Sorry.
Int.
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 Okay. What does it actually do compared?
Compares to strings.
Yeah, compares two strings lexicographically. Perfect. Now the fourth function, equals, right? What is equals? What is the input parameter there for equals?
String.
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 What is the output data type? What were the like
Boolean.
Boolean? Perfect.
Boolean.
One more good way to think about this is right. Whenever we are using inside if function, I mean if statement, what sort of data types can go with if?
So like else.
No, the data type we use inside if, right? If statement. What should this necessarily equate to? It should be a what value? Okay, I'll give you a question. It has to be a boolean. Okay, I'll tell you why. Now I come to let's say Achintya or someone, right? I'm like Achintya, if you have a big car, let's go on a long drive, something like that. And Achintya, he tells me, bro, three. He's giving me an integer value, right? He's not telling me yes or no question. So what I tried was, if you have a big car, so necessarily his answer should be yes or no. He can't give me something like, bro, 3.5. I'm like, bro, do you have a lot of money? He's like, bro, Achintya. He's giving some other answer that is not important for me. When I ask a yes or no question, I expect to receive a yes or no question. So yes or no, in what data type do we represent in programming?
Boolean.
Boolean, exactly.
Boolean.
If statements necessarily must be combined with our Boolean this thing, okay, Boolean values. So that is why one trick there, because I used Ramesh dot equals Ramesh here, that means necessarily the return data type of it must be a Boolean. So that is why I'm able to use it. Okay, so that is one more thing that you guys can remember. Now coming to the last function, substring. Okay, it's for now, just remember as a general rule of thumb, booleans can be used inside your if statement. Okay, there are some exceptions to that. We'll not be handling that now, but just remember it's a good way to think about things. If you have something like equals, it's like a question, right? Is Akshay's marks equals Mithila's marks? So I'm asking a question. So equals will equate to a boolean. So that is what I wanted to tell. Now substring. Okay, we have come to a very important string. So let's see, string short name is equal to Akshay dot name dot substring 0, 3. Okay, so what do you guys think? I've written out this function. So what do you think? What do you guys think this may do?
I think it will accept only 3 characters.
That's such a good answer. That's such a good answer. It will take 3 characters from the name, but what 3 characters?
The first till the fourth one.
Perfect. So the first till the fourth one, or first, second, and third, we can say. Okay, so let's just try and print it out. System.out.println short name. So what should be my desired output here? What do you guys think will be printed? So where is
AKSH.
AKS? Yeah. That's a good guess, AKSH. But why is it AKS? I'll tell you. Right. So you guys know, right? In our programming language, even strings are indexed from 0 onwards. Okay. So when I write something like KSHAY. Okay. Let's see. Now, what is the starting index of Akshay?
0.
0. Okay. Now I'm saying name.substring start from the 0th index and go till the 3rd index. So what it's basically doing? A, K, S, and it's saying okay, I'm not going till means it's not inclusive of the 3rd index. So start from here and go to 1 minus of this index. So it gives me A, K, S. Okay. Now, just to check our understanding, what should this print?
H.
Will it only print H?
Sir, SHA.
SH. SH?
SH. A.
Hmm.
Only,
SH.
Yeah.
no, it's only SH.
Only SH. Let's see. Let's see. We are all trying to understand this. Let's see what it does. Okay, it prints only SH. Okay, I'll tell you why. It starts from the second substring and goes until the fourth, but technically it's actually going one less than it. So S and H. Okay, let me say we are all standing in front of our school road. Okay, and I'm telling bro Akshay, go till the school gate. Okay, he is walking till the school gate, but he won't try to enter the school gate, right? He won't try to enter school. He won't enter the school gate, so he's just going till the school gate, but he's stopping before the school gate. So that is what how you guys can understand. It will start from the second index, but it will go up to one minus of the second index that's stored here. So one more example, just to see, just for our own sake, what will this give?
KSHA.
KSHA.
Let's try. I think our
KSHA.
understanding is good now. KSHA. Okay, perfect, guys. Perfect, good work. Now let's see. There is one more thing. Okay, it says name.substring, and it only gives one input. So what do you think this might do?
It will print A.
It's okay. That's a very good guess. Name the caret. One will print only k. So that's a good guess. Any other guesses? It's saying substring. So I am asking the computer for a substring, but I'm not specifying. I'm specifying one value. I'm not specifying two values. What do you think this computer may do? Any guesses?
An error.
That's also a very good guess. That's also a very good guess. An error may also be printed. Usually in functions, right? Those things like if you don't give the right input parameters, they give errors. But sometimes there are certain functions called overloaded functions. That means they have the same function name, but they can accept multiple input parameters. So substring is one of those functions. Now I'll give you another clue. When I say substring 1, I'm basically telling the computer to start from the index 1. Okay, now can you tell me what the output might be? It's I'm telling start.
Only K.
Only K? Not quite. Any other guess? Any other guess? It's a good guess.
KSHA.
KSHAY. Let's check that out. Let's check that out. KSHAY. So basically that, okay, whenever you're specifying only one index, okay, so basically what we're telling the computer, start from that index and go until the end of the string. How many other characters are till the end you go? Okay. Now another thing, what will this bring?
KSHA.
AKSHAY. So basically when you write name.substring 0, basically you're asking the computer to print out the whole string. And what would this do?
Error.
Error. Beautiful, beautiful understanding, guys. Okay, basically it's I'll tell you what's happening. It's actually not quite an error. It's a logical error. More of that. 6, right? Basically there is no index after that, so it's not able to get any. It's not able to find any character there. So it's basically telling, relax, bro. I have not found any character. You can go ahead with no string. So it's not a compilation error or something like that. It's just like a logical error on the hands of the programmer. You're not getting any string back. Okay, what would this do?
SHA1.
SHAY. Okay, perfect. SHAY. Yeah. So this is our how the first four functions that we have read, guys. SHAY. So now, before I will just do a small activity after this, but before that, I just want to tell you about the next function, right? Contains, because this will be using in our next activity. What do you think contains may do? See, again, I don't know. Equals, contains. It's almost like a question, right? Is that This I'm very bad with language, guys. Have some patience with me.
I think contain means like to check if that character is there in the strip.
Perfect, perfect. To check if a character or a set of characters are basically to check if one string is there and another string. So what did I give you? I gave you guys one key to understand these problems, right? If they end with S, right, it makes it look like a question. So what should that return data type of contains be?
Boolean.
Boolean, perfect. See that's like our small tricks that we build to understand programming. So whenever it ends with S, right, it basically means like the expected data type is Boolean. And what did our friend here tell? He told, right, it basically checks if one string is there in the other string. Okay, so let's see how that works. So if name dot contains ks system dot. Okay, so what do you think this will output?
Yes,
Yes, why?
because KS is there in the name.
Yeah, because ks is present in the original name string. So let's just see how that works. Yes, okay, perfect. Guys, so these are the first few functions that we learned today. I don't want to go through all the strings and then forget next time and like that's not good, right? So let's actually try and build a small activity out of that. I hope everybody understood what each of these first six functions do. Any
Yes.
doubts? Any doubts, guys? You can ask me. We can go over it because it's more important that we understand what each of these functions do. All good, guys? Okay, perfect. So this will be a small activity, okay? Let us try design a small phone book with names and the ability to search for specific contacts by name. Okay. So what does a phone book generally have?
The name and the telephone number.
The name and the telephone number. Good, good, good thinking. So we are going to store a set of names and we are going to store a phone number, right? So in what sort of data structure should we capture this data? Hmm. Should I write something like string name one is equal to name one is equal to this string name two name three. Do you think this makes sense? Storing hundreds of names like this.
Understand like the like what does like a small phone book.
Okay, sorry. I'll just describe what a phone book might be. Paint. Okay, so I don't think many of you guys would have seen this yellow pages or something. Okay, so basically it was like even before my generation kind of thing. So people used to have this. Sorry, very bad artist guys. You have to bear with me. So it used to be like this big book. Okay, it used to contain the names and the phone names and the phone number names and the phone number. So and these names, right, were arranged in lexicographical order. So when I wanted to find out what Akshay your number is, right now you have like true color or something, right? That time it was not there, and that time the benefit, right, not a lot of people had phones or numbers and stuff like landline numbers, so only a very specific set of people used to have it. And then this yellow page used to come to all these houses and stuff, and then you could search for people's numbers through this yellow page book, okay? Or I think it's yellow book or something it's called.
So does it contain the people of that particular area?
Yeah, that's also a good guess. It may contain the area, people of the particular area, or like the important services in the area. Right now, if you want to go to the dentist, you just go to Google and see like what's the dentist near me, right? So what you'll do that time is you'll go find out who are like any dentist name near your house. Then you go search for this number in this yellow book and then. So that is basically what a phone book is, okay? So it used to contain these names and used to contain their numbers. So let's try and design that, okay? I hope all of you understood what a phone book is.
Yeah, sir.
Yeah, perfect. Now the phone book has like multiple names and it has multiple numbers associated with these names, right? So what sort of data structure should I store them in? And I think only one data structure you guys are exposed to of so far. I'll tell you what it is. It is an array, right? Can anybody tell me what an array does? Any guesses, guys? Or have you guys started arrays?
So they didn't teach it yet, but it is there in the portion.
Yes.
Okay, but you guys haven't been taught it yet, right?
No, sir.
Okay, then perfect, not an issue. And one basic thing I'll just tell you. An array, right? It basically will have a certain name associated with it. Sorry. Just bear with me, guys. I'm just trying to plot this out. Okay. So let's say this is an array of names. Okay. And you will have the same thing indexes here. And all the names, right? You will store it in a series. Like it'll be like contiguous memory location. So in that sense, it'll be like continuous memory location. So this will store Akshay, this will store Achintya, this will store Arav, this will store Aaron, something like that, right? So in contiguous memory locations, the values in the array are stored. And how do you refer to the first element in this array? It's very simple. You just write names. My God, my handwriting is too bad. Names, and you call it by the index name, right? So that is how you call the ith index element in the array. I'll just write out the first part for you guys, and maybe you guys will have a better understanding of how elements are stored in the array. Okay, to get started, first we'll need a set of names, right? So string names is equal to, and this is basically how you initialize arrays, okay? Aaron, Arav, Ramesh, sorry, Sukesh, and Bhupesh. Bhupesh is also a good friend of ours. Bhupesh. Okay. Now in numbers, okay, these are their respective phone numbers. Again, we are going to have an array of strings. So let's say Aaron's number is this, Arav's number is this, Ramesh's number is this, Kumesh's number is this, and Bhupesh's number is this. Okay. So basically what we have done is I have stored the names and their respective numbers in two arrays. So the first number is Aaron's number, second number is Arav's number, third number is Ramesh's number, fourth and fifth and so on. So just before we get into the action program, I'll just show you how to print out the values in the array. So you go for int I is equal to 0. Loops you guys have done, right? For loops.
Yes, sir.
Yeah. So names dot length. So names dot length will actually return the length of these strings. Okay. So the length of these strings, length of this array. Sorry, length of this array. So this array contains how many elements? The names array. How many?
Five.
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 1, 2, 3, 4, 5. Exactly. So names dot length gives how many array elements are there. Okay. So what values will I take in this follow?
So 0.
0. Then next.
You increment to 1, then 2.
Yeah. Until which value?
So 5.
Until 5. It is because we have mentioned I less than 5, right? We will stop at
5. So 4
yeah.
technically.
So again, right? Because array elements are indexed from 0. So the index of array will be 0. Index of Ara will be 1, 2, 3, and 4. Okay. So this is what the indexes how they are stored in the array. So now in order to print out, this is very simple. System.out.println names I. Okay, so basically to tell you guys, when I say names, open square bracket, close square bracket I, right? So basically in the first iteration it will be names of 0, right? So it will basically return me the value that is stored in the first index in this array. What is the value stored in the first index?
Aaron.
Array, perfect. So it will basically return me array. Now plus sorry, numbers I. Okay, what do you think this will return me? Numbers I.
So like the a number of Aaron 3214.
3214, correct. So the first index element in numbers is 3214. Okay. Now I'll just do something like this. What do you think this does? Sorry. Okay, I'm system.out.println. That's not necessary. Okay. Let's just print out and see what the result is. You guys can see this, right? Aaron 3214, Arav 1424, Ramesh 3124, Komesh 9999, Bhupesh 000. So that is how you print out the printing out the phone book. Okay. Now we have basically stored all our names in the phone book, and we have also printed out their numbers, right? Now what should our functionality in the phone book be? Basically what our phone book does is, right, it asks the user if there is any name he's searching for, and it'll try to match that name in the our phone book and give that number to the user. So what should we do? What would be the input be that time? We are going to basically ask the user, hey, do you have any name in particular that you're searching for? So then he enter a name or a substring of a name, and we have to try and match that with our phone book and return the appropriate number, right? So what would be this thing there? Input. Taking the
So like after asking the name, we have to compare to the
array of names. Yeah. So first thing what you have to do is take the input search query, right? In Google and all, right? You right. What is tomorrow? What date is tomorrow? So that's like a search query, right? You're giving a question to Google and it will return the search results. So right here, our search query will basically be a name or a subname. Subname basically means like a few characters in the name. Okay. So now taking the input, to take the input, what class do we use?
scanner class.
Scanner, perfect. Scanner is equal to scanner system.in. Okay. So we just prompt the user to enter the search string. Hey, enter the name you want to search for. Okay, so string search query is equal to sn dot next line. Okay, now we have gotten our search query, right? Now what we have to do next is we have to iterate through our array of names, and we have to try and match the search query to the name, right? And if these two at least partially match, we have to output our output that specific number. So can you tell me any function? We learned so many functions, right, today, like in this session. Can you tell me any function that can be used to match two strings?
Equal.
Equals. That's a good answer. That's a good answer. So iterate through the phone book and match the name. Okay. So for int I is equal to what? From which index should I start matching? 0. Perfect. I less than?
Usually 5
Yeah, 5, or we can even say names dot equals. Right? Now we have a names
names.
function. You have to iterate those many times. Names dot length. For some reason. Oh, this is the reason. Right? One more thing that we have to remember always is that inside the for loop, it's not commas, it is always semicolons. Right? Even I made a mistake right now. So it happens, right? Int I is equal to 0, names dot length, I plus plus. Okay. Now what we have to do is if what should I write here? I'm trying to match the search query with the name in the array. So can anybody guess what would go here? And you guys gave a good answer. Yeah.
It'll be if search query dot equals names bracket.
That's a good answer. That's a good answer. Names, and will this work?
I inside I.
Perfect. Perfect. So if search query dot equals name, system dot print name found, system dot out dot. The same thing we can print here, right? Something we have printed here. That. Okay, so let's just try running this program and see what output it gives. So, okay, so this is our phone book. Okay, it says, hey, enter the name you want to search for. Okay, I'll enter Aaron. Okay, so name found Aaron 3214. So see, right now, right, we have built a small phone book for ourselves. Right now, let's go back to a previous problem that we are facing. Let's say Aaron, right? Now, okay, this is not good. This is not good. So what should we do?
Use a different function.
Yeah, use a different function. Straightforward solution I told, right? Something you add to this equals, then it will give the correct match. What was that new function name for?
Ignore case.
Perfect. Ignore case. So when I do this, let me run it again. So let's say if I even enter Bhupesh. Okay. Now name found Bhupesh. Wow, our thing is working. But usually what happens, right? When you're trying to search for, see, now we already have a very good functional phone book, and just from a basic string functions, we have built out our phone book, right? But sometimes the user does not always remember all the letters in the name. He remembers something like Boo, right? And he'll want all the names associated with Boo, right? So, and okay, not good. I'm not getting any names. So what can I do there? Is there any other function? Contains. Beautiful answer. So what does contains do? Can anybody tell me?
It checks whether that character is present in the string or not.
Yeah. So can you tell me how should I replace this function now? If so, now we are not going to use equals function. We are going to use contains function. Okay. So tell me, how can I rewrite this function? If
names bracket I dot contains search query.
perfect, names bracket I dot contains search query, then same thing, system dot out dot println. Okay, now let's just run this. Okay, enter the name you want to search for. Let's say AA, right? These I just remember the first two letters of somebody's name. So see, it gives me Aaron and Aaron, right? Perfect. One more thing, right? See, this one I just have to check for now. Is ignore case available here? Ignore case, or is it automatically ignore case? One second, I'll just figure it out, guys. In 2 minutes. A. Okay, so it doesn't automatically ignore case, right? So now we have come to a big problem. We have solved the problem that if what happens only when we know a few letters of the name, we don't know the whole name. Now we have another problem. we don't know a way how to ignore the case and search using contains. So can anybody give me a suggestion how we could do that? The problem here is the cases don't match. So can anybody just figure out a way where we could match two strings? What should we do? We have a problem with the case. So can you tell me? Can you guys suggest some suggestion? This function we have not studied so far, but can you guys just tell me the basic gist? What problem we first have to solve? I'll just write it down. We have a problem when two strings have different cases. So what can we do?
Can we use the and operation and then put a different function?
Yeah, that's also a good solution, but we are again making it more complicated. So we have a problem when two strings have different cases. So what one way to solve this? What happens if we make them the same case? Let's see how we do that. So search query. We put search query dot to lowercase. Okay, so basically, let me just reiterate what I've done, guys. So I'm telling whatever search query you get, convert every letter in that search query to the lowest case. And when you are comparing the names, convert the name also to the lower case. So something like, Aaron would be converted into Aaron, and our search query, which was AA, would be converted to AM. So now we can compare, right? Both are in the same case. So that is how we have worked around that solution. So now this comes to our new function dot to lowercase, right? So just to reiterate, name dot to lowercase, to lowercase. So what is the, have we not defined name? Sorry, search query. What are the input parameters for this function?
String.
String. And what is the output data type? So I'll tell you,
String.
string, perfect. It takes in a string and gives out a string. But what does it do to the string it takes in?
It makes it all lowercase.
Perfect. It makes it all lowercase. So that is our seventh function of the day. Lowercase. Dot to lowercase, right? To lowercase. That is our function. Okay. Now let's try running this program one more time. So I'm just going to write AA. So as you see, right, so basically in the backend it converted this also to a lowercase AA, and then it compared these two strings and returned me the matching strings. So this is how with our basic string functions we can build a phone book. And some of the key learnings here, right, we learned that we can use multiple functions to solve a certain problem, but the difference is each function does something different. And in order to implement one feature or another, right, we have to use the right function. We were very happy using the equals function and equals ignore case function. But what was the main problem there when we used equals and equals ignore case function?
It's not valid for all cases.
Yeah, it's not valid when we don't know the whole string we are matching. Only if we, like, there are many instances, right? We only know a certain part of the string. We don't know the whole string. So that time we can't use equals and equals ignore case. Then we realized, okay, we can use contains. But what was one more problem that we encountered using only contains?
Is it the uppercase and lowercase letters?
Yeah, the problem is uppercase and lowercase. Then what? How did we solve it? By using the two lowercase function.
Two lowercase.
Guys, like we try to build a small application with our knowledge of strings, and first we solve it in one way. We try to find out what the advantages and disadvantages of that way are. Then we try to implement other functions or make changes. And when we implemented other functions, right, we got new problems. And how we solve the new problems. And once we solve them, we got a final application. So this is how we can build, like, when you just look at this, right, it's a full-fledged application as it is. We have a functional framework with the ability to search for a certain name. And it's very useful also, right? You can store the names of all your friends in your computer, and you can just write a substring of the name and get their phone number out. So basically what we have done in like last 15-20 minutes, right, we built a full-fledged application. So this is one more learning experience for us. Whenever we learn something new, right, strings, integers, or whatever, always try to build like these small applications out of them that are useful. So it will always motivate you to learn more about what these functions are and what they do, and how you can go ahead from there, right? So that is one more key learning area for today. Anything else, guys? We reviewed 7 functions today, and we saw how each of them work, and we also built a small application out of it. Anything else, guys? Any doubt as of now?
No, sir.
Okay, anybody
So
else?
can you repeat what does that second function concat do? Like it adds a second string to the end of the first.
Exactly. So let's just see string initial is equal to hello, string end is equal to world system dot out init dot concat. And okay, so let's just see hello world. Okay.
Oh,
Any other doubts, guys?
Sir, can you explain substring again?
Okay, substring. Yeah, perfect. That's a good thing. So let's again try to do a small activity. Okay, with the substring function. So let's say I'll just print out my name. String name is equal to Vaishnav. Right. And let's say I wanted to print my name in such a pattern. Vaishnav. I hope you guys are understanding what I'm trying to do, because even I'm not understanding what I'm trying to do. Yeah. So this is the sort of pattern that I want to print out my name in. Okay, in the computer. So how would I achieve this? Let's see. Yeah. For and I equal to 0, I below name dot length -1 I plus plus. Okay, system dot out dot print name dot substring 0 comma I. So let's just see what this prints out. Okay, what have I done? Oh, printed out in the reverse. My bad. Zero comma. Oh, name dot length minus I. So let's just see. Yeah. So this is the pattern that we were looking for, right? So let's just run through each line of the code so we actually understand what the name dot substring function is actually doing. Okay. So in the first iteration of this loop, what is the value of I? 0, right? So it says name dot substring 0. Name dot length, what does it do?
The length of
the amount of letters in the string.
Yeah. So what is the length of name?
7.
7. Okay. One more key understanding here, right, guys, is that when you have a string of length 7, what is the maximum index that the
6.
6? Perfect. That's a good answer. Right. So that is the maximum index the string can take. Okay. So in the first function, I value is what?
0.
First iteration, I value is 0. Name dot length is, what is the value of name dot length? What do you think that should return?
Like 7.
7, yeah. So in the first iteration, the value of the whole thing is
0.
no, name.length is 7, I
Oh,
is
well done.
0.
Okay.
So 7 minus 0 is 7. Okay. In the first function, this is the value of I'm getting 0 comma 7. Okay. Now can you tell me when I write name dot substring 0 comma 7, what will that print? What can you tell me what characters will come out from which index to which index?
0 to 6, like everything will be printed, I think.
Exactly. So it starts from the 0th index and it goes until 7th index, but it won't capture the 7th index. Okay, it will go until the 7th, means one less than that will be captured. So V, Y, S, H, N, A, V. So that is what will be printed in this. Now what happens if I do this? It will start at the 0th index V.
VYS.
VYS, perfect. So let us do that. This, I think that's better for our understanding. Yeah. So it has to print VYS, right? Let's see if it prints that. Okay, now what does this do?
It only prints such.
Edge, perfect. Okay, so now that is what name.substring does, right? It starts from this index, third index, and goes up to the fourth index. So it starts from the third index and it's already up to the fourth index. It can't go any further. So it's only prints H. So now what does this do? 5, 6.
Only A.
Okay, perfect. Now coming to the next sort of, see, in all these first few functions, right? How many input parameters are there? How many parameters are we supplying to the substring function in the first type? This is the first type.
2.
2, exactly. And what data type there?
Int.
Integer values, correct. We are specifying two integer values, specifying the starting and the ending index. Okay. Now comes to the second type of substring function. We are only specifying one index. Okay. Now what is the difference between this and the last one?
This has only the starting index. So
Exactly. This has only the starting index, and we're not specifying the ending index. So by default, the ending index is considered to be the end of the string. So when I do something like substring 2, right, it starts from the second index and it goes until the end of the string. So it will print S, H, and A, B. So let's just see if that's the case. Yeah, as such enable. So that is what this substring function does. When you're not specifying to start and end index, it automatically assumes the end index is the end of the string and it operates based on that. So that is the difference between supplying two parameters and one parameter. Anything else, guys? I hope you understood what the substring function does.
Yes, sir.
Yeah, everyone,
yes,
right? Yeah, perfect. Anything else, guys? Any doubt?
No.
Any doubt in length, concat, compare to, equals, substring, contains? Okay, two lowercase.
no sir.
No, right? And one more. Now, see, because you guys know for loops, this again, and we also understand the concept of indexing in strings. So now let's come to this thing. Okay, reverse a string. Okay. Now let us write a program to print the reverse of this name. How would we do that? Whenever we are trying to print the reverse, right, from what index to what index should we go?
So from the last to the first.
Exactly. Now, in this name, sorry, just to print that again. So, in this name, the last index is what?
6.
6. Okay. Can you tell me in another way? The last index, if I'm using a function called name.length, how is the last index related to this function? Name.length basically it tells me how many characters are there. And I always told the value of the last index is in what relation is it to the length?
So length minus 1.
Length minus 1. Beautiful answer. So let's do that. For n, I is equal to name dot length minus 1, and it should go until which index?
0.
I greater than equal to 0. Then
I minus minus.
I minus minus. Perfect. Now system dot out dot println. Okay, guys. Now we are going to come to another important function. It's called caret. Okay. So I mean, again, it was the schedule for tomorrow, but we can just take it up now. It's a caret. Okay. Now what caret does, it basically takes the character at that index of a string. So when I say name dot caret I, what do you think this does? Name instead of this, if I write name dot caret 3, can you guys tell me what this should output? Name dot caret 3. Okay, so now what is the input parameter here?
So height.
Int, yeah. Int is a position. Output data type. Oh, I just realized you told n. Okay. Sorry about that. Okay. Input parameter is an integer data type, and output data type is, we're saying give me the character at third index. So what should be the output parameter?
So character.
Character, exactly. So basically it's saying give me the character at index 3. What is the index 3 here? Character at index 3?
H.
H, correct. So right now when in this, right, when we are trying to reverse a string, so basically we read the string backwards from the 6th index to the 0th index, okay, and then we're telling give me the character at index I. So in the first iteration, what value will I get here? Name dot caret I.
So like I have a doubt in that for loop you put int I is equal to name dot length. So name dot length minus 1. So name dot length is 6 there and getting 6 minus 1.
Name dot length is 1, 2, 3, 4, 5, 6, 7, right?
7.
Yeah. So 7
Okay.
minus 1. So it will give the last index.
Okay.
So no matter what name, it will give me the last index. Alright? And we
Okay. Yes.
yeah. So name dot caret I. So in the first iteration, what will you print it?
So
V. Which V? Shit, my name is
Last
bad, guys. I'm very sorry about that. Okay, let's say my name is Vaishnav. So what letter we print first?
so Y.
Y, exactly. Then in the second iteration,
A.
yeah, so on and so forth, they'll come to the first letter. Okay, let's just print it out and see. So Y A N H S Y V, right? So that is how it's printed. Just to make it simpler, I'll just print everything out in the same line. So this is how we get our output. Okay. So now that we have understood this, now tell me, instead of printing this string out, I will actually want to store it somewhere. How would I do that? Instead of printing it out, I'll have to store it in another string. So how could I do that? String.
So using the concatenation function.
Oh, that's also a very good idea. That's a very good idea. But there is a simpler way that's usually preferred. Basically, strings, right? You can operate them the same way as you operate any other data type, right? Like integer, character, and stuff. At least for this purpose, like appending, they do something different. I'll tell you. Rev is equal to rev plus name dot caret I. Okay. So what basically this does is, right, what is the initial value of rev? It is a empty string, right? It will have this value. Okay. Now what is the value of name dot caret I in the first loop? In this program?
So
E, exactly. Okay. So now rev is equal to empty string plus E. So what finally these two things will get added, appended to it. I mean the second one will get appended to the first one and get stored in rev. Okay. Now we have E plus What is the second loop?
L.
L. So now E plus L will get added up and will get stored here. Now EL plus P, right? And so on and so forth, we'll get the reverse of the original string inside ref. Okay. So basically, that's how instead of printing out, I'm just appending, like I'm reading the last character and appending it to ref. I'm reading the last character and appending it to ref. I'm reading the last character and appending it to ref. So that is basically how you can operate. This basically simply works because this is our character and we are appending it to the end of our ref string. Okay. Now let's just print out this system dot out dot println ref just to see if we have understood if we can reverse a character correctly. I mean reverse a string correctly. So let's try that. As you guys can see, right? This is the reverse of the original string. And now it comes to one more important understanding. You guys know what palindrome strings are?
Yes, sir.
Yeah. So what are palindromes?
So it's the word in a sentence which can be spelled the same way both backwards and frontwards.
Exactly. So now see, we have the reverse and we have the original starting string, right? So now how do I check if the starting string is a palindrome? I have the reverse in ref and I have the original string in name. I want to check if name is a palindrome. How would I do that?
If name equals who equals.
Name dot equals
Yes, sir.
name dot equals ref. Correct. System dot out dot it is a palindrome. It is a palindrome. Else system dot out dot println it is not a palindrome. Okay. So let's just try. What output will I get for the word apple?
So it's not a palindrome.
Not a palindrome. Okay, let's see. It's not a palindrome. But a word like mom, what should I get?
It is a palindrome.
Yeah. So yeah.
So
So that's what we're done, right? We're basically reverse the string and we're using this function dot equals to check if the reverse and the front is the same. And based on that, we're printing whether it's a palindrome or not a palindrome. So this is basically how, guys, like we just had like these basic string functions today. And with these functions, we can do so many like useful things and we can implement so many useful features with that. So that is how to reverse a string. And any doubts, guys, with the last program?
no, sir.
Yeah. Anybody else? No doubts?
So we are just using strings to make the programs a bit more easier,
Like easier, I wouldn't say, but you can.
but shorter.
Yeah, you can add so much more functionality with strings and functions and like that, right? Right now we are just adding numbers and stuff like that. But today we saw a real world application where strings are very useful, like matching the phone book and something like that. You guys can probably think of another activity that we can do tomorrow. Probably some application that we can build, small application like what we did today using strings, and maybe you can suggest it and we'll try implementing it as an activity tomorrow. Right? You can you have my number on the group, right? You can just suggest an activity and we'll try doing it tomorrow. Yeah, perfect, guys. If there is no doubt right now, then I think the class is also we have run out of time now, and I hope you guys learned what the 7 basic functions and strings are, and I hope this is adding value to you.